You probably wonder why we haven't talked about three shaders yet: Principled BSDF, Principled Volume, and Hair shaders. It's because it was good to learn about all shaders separately first to understand what is really happening when you use them. For example, only glossy or transparent shader. Principled BSDF shader combines multiple other shaders that we mentioned earlier into one, and it's pretty friendly to use. It has some new cool functions too. We'll go through the options real quick, as we'll talk more about this shader in the next course when we'll talk about PBR workflow. For all of the cases, I will show you the principal shader on the left and the separate shaders or a mix of them on the right to show the differences. Base color in principal shader is used for adding color to diffuse, subsurface, metal, and transmission. Now I'm changing only the diffuse color. I'm not changing any other parameters. Next up, we have subsurface scattering. Weight in subsurface slider is a blend between diffuse surface and subsurface scattering. It's like turning the effect on or off, so if you want to use subsurface, we should set it to 1. The scale slider works exactly the same as in subsurface scattering node. It should be kept a pretty low value for small objects because it's object size related. With the subsurface radius, we can change which wavelength gets further through the object. By default, it's a skin-like material. That's why we see a very delicate reddish tint because red light scatters deeper. And we also have different subsurface methods, the same as in the subsurface scattering separate shader. The specular component controls the metallic and specular layer on top of diffuse and subsurface. The IOR value increases or decreases intensity of the specular layer. 0.5 means no adjustment, 0 removes the reflections, and 1 doubles them, so in general, it tells us how reflective the surface is. With metallic input set to 1, cycles will ignore this value because we've already set it with the metallic slider. The tint color allows us to change the reflection color of metallic materials. We can leave it white for other shiny surfaces like plastic, but for artistic purposes, you can change it to other color. But remember, it's not physically accurate. Transmission is used to render materials like glass or liquids. To make a glass material with principled shader, we need to set the transmission value to 1 and turn the roughness value down, and we're done. The coat is a component that allows to create a layer above any else, such as clear coat, lacquer, or car paint. I will set the base color to light blue and roughness to a very small value. To be physically accurate, the coat weight should be set to 0 or 1, but it might have a slight differences across the surface, what can be done by using textures. We can change the roughness of the coat. The index of refraction value affects the reflectivity and the falloff of the coat tint. Sheen, like in the Sheen BSDF, simulates small fibers on the surface. Let's make a red fabric material with yellow colored sheen. First, I will change the color of the base color and then the sheen tint. The weight value controls the intensity of the sheen layer, so it influences how reflective is the surface when viewed from an angle. Roughness determines the shininess of the sheen reflection. Emission is pretty self-explanatory. The object emits light. We can set a color and a strength of the emission. And lastly, thin film. It imitates the effect of the soap bubble or gasoline puddle. The thickness parameter describes how thick is the layer of the film on the top of the surface. Depending on that, we'll see a colored reflection from the layer of thin film and the base material. Index of refraction value set here might be different than in the top part of the principled node and describes the index of refraction for the thin film layer. So to give you an example, let's make a soap bubble. First, we need to create a base material, so for bubble, it will be air. So we need to set our IOR value to 1 and transmission weight to 1. Bubbles are glossy, so we will change the roughness to 0. Then we can go to the thin film thickness and type here, let's say, 800 nanometers. So bubbles usually have a thickness of 10 to 1000 nanometers. We'll set the IOR to about 1.4 since it's made of water, whose IOR is 1.33, and soap, whose IOR is 1.5, and the average refractive index would be somewhere in between. And now we have a pretty nice example of a soap bubble. As you can probably see, the principled BSDF is extremely powerful, combining all the functions that base shaders have, and is used very often. In the next course, we'll use it to see how the textures work. Another shader that we haven't talked about is principled volume. On the right, I have two shaders added together, the scatter and the absorption volumes. And now let's change parameters on our left shader ball. You can see that with a little bit of tweaking, we achieved pretty similar result. So we can say that principled volume shader is a combination of volume scatter and volume absorption nodes. We can control the density of the volume, and it's very handy when making smoke or fire simulations. After baking a fire or smoke simulation, we can put some attributes describing the strength, density, or temperature of the volume. It's very useful for trying to achieve a realistic materials, as all the information are stored as easy-to-use attributes. We can also add emission to the volume and change its color. A blackbody intensity allows us to change the emission of the fire that depends on the fire temperature. Lower temperatures emit more red and orange hues, higher temperature emit blue and white hues. To be physically accurate, the value should be set to 1. At the bottom, we have the temperature, and we can see that with 1000 kelvins, the blackbody intensity is pretty weak. So let's change it to the hottest flame temperature ever produced, about 5260 kelvins. It definitely got more intense. You can change the tint of the blackbody above the temperature slider. Last shader we'll talk about is the principled hair BSDF. Is it a physically based, easy-to-use shader for rendering hair and fur? There are two main scattering models, Chiang and the newer one, Huang. There are also a few options for color parameterization. We'll focus more on the melanin concentration method, though, along with the Huang scattering model, as it also supports the elliptical cross-section of hair and it gives the most realistic results. Most of the parameters are very similar, so we'll start with direct coloring parameterization, in which you can change the hair color no matter if it's realistic or not. Now we'll switch to the melanin concentration, and this mode will allow us to define the color as the quantity and ratio of the pigments that are found in hair and fur. Melanin describes the quantity of the pigment. 0 melanin results in white hair, while 1 is a black hair. Melanin redness is the ratio of the pigments, and increasing the value will result in more saturated color. The tint input allows to dye the hair with the desired color. The darker the hair, the more difficult it is to give it a tint, what is pretty realistic. Aspect ratio describes the ratio between the minor axis to the major axis in the elliptical human hair cross-section, and the values should be set according to ethnicity. The roughness specifies how much the reflections are smoothed in the direction of the hair shaft. Low values will add almost a metallic look, high values will result in a diffuse look. IOR defines how much the ray changes direction. At 1.0, rays go through like in the transparent material. Above 1.55, rays are more refracted. Offset value lets you adjust the angle of the hair's shiny reflection by changing how the outer scales of the hair lie against the hair strand. Random color and random roughness are self-explanatory. They're adding some variance to the hair. Last three parameters are optional. Reflection modulates the first bounce of the hair surface. Transmission adjusts how much light passes through the hair. Secondary reflection adjusts how much light goes into the hair, bounces around inside, and then comes back out and affects how the hair's internal color shows. All of these three values should be set to 1 for realistic results. Go ahead, change some values, and turn into a virtual hairdresser. That concludes all the Principled shaders. I'm sure you'll be using them the most out of all the shaders, especially the Principled BSDF, as it's very convenient and after knowing a bit more about it, really easy to use.